Antelope's amazing horn spirals, why how? Antelopes truly are a marvel to behold as they navigate their habitats, whether it's leaping over fallen logs in dense forests or sprinting across vast grasslands. Their speed and agility are legendary, allowing them to evade predators with breathtaking grace. But beyond that incredible athleticism lies another captivating characteristic: the spiraling horns of many species. These aren't just simple projections, they're intricate works of natural art, often twisting and curving in complex patterns that vary dramatically between different types of antelope. Stick around. You're about to learn something wild. But first, tap like and hit subscribe so you don't miss the next mind. The spiral shape isn't simply for show either. It can play a role in combat during mating season or establishing dominance within a herd. Each twist and turn tells a silent story of evolution and adaptation. Antelope horns are truly remarkable. While many animals develop horns that grow straight up from their heads, antelope often display something far more intricate. You'll notice a fascinating complexity in their horn structure: graceful twists, elegant curves, and sometimes even spiraling patterns. This isn't just random growth. These shapes can actually be indicators of the animal's age or health, and they contribute to unique visual displays during mating season. The way light catches on those complex surfaces creates stunning patterns that are a real feast for the eyes. It's one more reason why these animals are so captivating. Those incredible spiral horns aren't just a beautiful accident, they're actually a fascinating demonstration of genetics at work. The shape and complexity of an antelope's horn are largely determined by the genes it inherits. Specific genes dictate how quickly the horn grows and, crucially, which direction it spirals in. This genetic blueprint can vary considerably between different species. You see far more dramatic spirals in some antelopes than others. Think about the long sweeping horns of a sable antelope versus the relatively straighter horns on an impala. That difference is directly linked to those underlying genes controlling horn development. It's a powerful example of how genetics sculpts such distinctive physical traits. The antelope's horn isn't just a solid structure, its formation is an incredible feat of biological engineering. As it develops, the bone that forms the horn grows in what appears to be a circular motion, layer upon layer, building outwards and upwards. What's truly fascinating is how this growth is guided. Underlying cartilage structures play a critical role here, essentially acting as templates that dictate the distinctive curve we see. Think of them like an architect's blueprint for the horn's shape. This process isn't simple. It involves remarkably precise cellular activity at every stage, orchestrating bone deposition and shaping the final form. Take a closer look at those magnificent horns. They aren't just for show. The way they twist and curl, that spiraling pattern, actually tells us quite a bit about the antelope itself. Younger antelopes typically have simpler, less pronounced spirals. As they mature, however, these horns become more complex, showcasing increasingly elaborate twists and turns. Interestingly, this isn't simply a sign of age. It can also reflect an individual's position within the herd. Often, older, dominant males will display the most impressive horn formations, a visual declaration of their status and experience. These grand spirals are a testament to years spent navigating social hierarchies and defending territory. The impressive horns you see on male antelope aren't just for show, they're a key factor in their mating success. Females often have very distinct preferences. Larger, more dramatically spiraled horns are frequently the most desirable trait. This isn't random chance, it's powerful selective pressure at work. Over many generations, this preference has driven male antelope to develop increasingly elaborate horn structures, as those with better horns were more likely to reproduce and pass on their genes. It's a fascinating example of how female choice can shape the evolution of male traits, resulting in these truly remarkable displays. These impressive spiral horns aren't just for show, they're vital tools for survival. Imagine an antelope facing down a hungry lion or a pack of hyenas. These horns become their primary defense. The unique spiraling shape isn't random, it actually helps deflect blows during confrontations. Think of it like redirecting force, making it harder for predators to get a solid grip. And when territorial disputes arise between male antelopes, those horns can inflict some serious injury, giving them an edge in establishing dominance and protecting their territory. It's a remarkable example of how form follows function in the natural world. It's incredible to consider what antelope horns are actually made of. They aren't bone, as many people might assume. Instead, they're primarily composed of keratin, the very same protein that builds our own hair and nails. Think about that for a moment. The strong, impressive structures on an antelope have a surprising connection to us humans. However, unlike our hair and nails, which remain soft, antelope horns are mineralized with calcium phosphate. This process adds incredible strength and rigidity, essentially turning this keratin structure into a durable, supportive framework, a truly remarkable example of natural engineering. Believe it or not, even something as seemingly fixed as a horn's shape can be affected by environmental factors. It's fascinating to consider how subtle differences in diet and nutrition actually play a role in their development. Antelopes require specific minerals and vitamins for healthy bone growth, and when those nutrients are abundant, we often see more elaborate spiral patterns emerge. Think of it like this: a well-nourished antelope has the building blocks necessary to create a truly stunning horn display. Conversely, periods of scarcity might result in less pronounced or even simpler structures. These variations aren't about genetics alone, they're a testament to how an animal interacts with and adapts to its surroundings. Antelope horns are far more than just impressive displays, they're living records of evolutionary history. By carefully examining their structure, the layers of keratin, the growth rings, even subtle variations in shape, scientists can piece together a fascinating puzzle about how these animals have adapted over time. Genetics play a huge role here too. Different genes control horn development, and changes in those genes, passed down through generations, lead to the incredible diversity we see in antelope horns today. It's not just about genetics, either. Behavior is intertwined with horn morphology. For example, male antelope often use their horns to compete for dominance or attract mates, so horn size and shape can directly influence reproductive success. Studying these connections reveals a complex interplay between biology, the genes and physical structures and behavior, how animals interact with each other and their environment. It truly highlights how evolution shapes not just what an animal is, but also how it lives.